This section is on 4.4 theorems about zeros of polynomial functions. So the first example what we're going to do is says finding a polynomial function of degree 3. So we know we're going to have x to the third because that says degree of 3. But it says also having the zeros of 1, 3i, and negative 3i. So what we're going to do is go backwards from this because previously we would have x to the third and then some equation and we would have to find the roots. But in this case, they're saying here are the roots. The roots are then 1, 3i, and negative 3i, and they're asking us to come up with the original equation instead. So to do that then, we're going to go ahead and substitute those things back into the parentheses. So when we have something like this, we're going to say x, and then when we put it back into the parentheses, we're going to go opposite sign. Because remember, when we have an x inside the parentheses, something like this, we always set it equal to 0. And when we set it equal to 0, we're saying that final answer is positive 1. So when we put it back into the parentheses, it's going to become a minus 1 instead, right? Because if I set this equal to 0 and I solve for x, x is going to become positive 1. The other one is going to become then x minus 3i and x plus 3i. And it's because we're doing the opposite signs of this, okay? So we're going to go ahead and I'm just going to put f of x equals. And eventually we're going to come up with an equation. So when you do this, my trick usually is to work on the i's first right here, work on this right here, leave this alone for the moment, and then eventually we're going to go ahead and distribute this right here. So you're going to do the distribution property or doing the foiling part of it. So if we continue on, I'm going to leave that x minus 1 here alone for the moment, and then distribute this. So x times x gives me x squared. Then I have is x times 3i is going to give us positive 3i. Then we go inside, negative right here will give us then negative 3i. And then the last one right here gives us negative 3 times 3 is 9. I times I is I squared. And so then from there we go ahead and combine like terms. So the middle term right here will cancel out right there. And then this goes back to the previous chapter, I squared. We can substitute that with a negative 1. So that becomes minus 9. And this is negative 1 right here, right? So then this becomes a positive 9 right there. So it becomes x squared plus 9. So now we're going to go ahead and bring this right here down. And we're going to continue on and distribute that. So it becomes x minus 1 right there. Okay, so we continue on. So then x times x squared gives us x to the third. X times 9 gives us 9x. Negative 1 times x squared gives us negative x squared. And then negative 1 times positive 9 gives us 9. So from here, I just need to make sure the powers are in order. So I have x to the third and x squared right here. So let's go ahead and put that in order. X to the third minus x squared. Remember, the negative sign always tags along with the variable right there. And then becomes plus 9x minus 9. So that is your final answer right there. So again, we're writing the equation in this case instead of going the opposite direction, which is finding the roots. So given the roots, then we're going to go ahead and write the equation instead. Okay? So let's go ahead and do the same thing for this one, example 2. This is find a polynomial function of lowest degree with a rational coefficients that have a negative square root of 3 and then also 1 plus I as 2 of its degrees. So what happens is whenever you have a negative or a positive square root, you want to do the conjecture. Remember, that's going to be the one that we talked about way back in the last chapter, early in last chapter. It's basically the opposite sign of each one of them, right? Or I'm sorry, the conjugate. So the conjugate of also the 1 plus I right here. Remember, the conjugate is just the I part of it. That's where the conjugate comes in. So that's the part that's going to change the sign. It's not the one that sign changes, but it's the I. So same thing with the square root. It's going to be the square root is also the sign that's changing. So when we write this equation up, you're going to actually have is now 4 parentheses because you have to do the conjugate. So the first part is then equals x. And then so the opposite of the square root of 3, negative square root of 3 is positive square root of 3. But since I have to do the conjugate, I'm going to go ahead and put minus the square root of 3. Because the whole point of this is when I distribute it, I should have no square roots of 3 at all, and I should get rid of his, yeah, so that's the whole point of that. And then this part right here, the 1 plus I, so when we write this, it's going to be x and then minus 1, and the only reason it's minus 1 is because right now, currently, this is positive 1 right here. So if this was negative 1, when I put it inside the parentheses, it becomes a positive 1, okay? So the this right here, the opposite is going to be this negative 1 right here, but when I write the conjugate, it's still that minus 1, but the plus 1 or plus I, that part is going to be the changing part of it. Do you see that? So this part right here doesn't change. That's exactly the same. And the only reason it's negative is because it's positive currently right here. So now this I part of it, I put a negative I right here. So now I have to find the conjugate of the negative I, which is then the positive I right there. Okay? Now this is going to become a little messy and stuff. So I would suggest doing this maybe in a box format, so that way you can have it a little bit more clear. So let's go ahead and do this part right here first, and then we'll do is this part the next part, okay? So when I do this part, I think this is the easier part. So x times x gives me x squared, so that's going to be x squared. And then this part right here is negative, and then this part is positive. So they should always cancel out. That's what the purpose of the conjugate is. So you don't even need to do the work for that because it should always cancel out. Now, if it doesn't cancel out, then you knew your sign was wrong because one should be positive and the other one's negative. So the last part is what you need, is this part right here, which is the positive square root of 3 times the negative square root of 3. So positive times negative is negative, and square root of 3 times square root of 3 is square root of 9, which is a perfect number, and it comes out to a 3. So this part right there is just these two parentheses right there, okay? Now the other one, it's going to get a little messy, so I'm going to go ahead and put this in a box format right here so you can kind of see that clear. So there's 3 variables or 3 terms, so I'm going to go ahead and do a box that's a 3 by 3. So that's 1, 2, and then 3 right there. Okay, so when I do my 3 by 3 box right there, I'm going to go ahead and put this one. It doesn't matter which one goes first on the top or the bottom or on the sides. Just put one. So on this one right here, I'm going to go ahead and put it on the side. So since this is x, I'm going to go ahead and put x. This is minus 1, so I'm going to go ahead and put minus 1 and then minus I. So that's this part right there. And then this part right here is on the top, so that's x. This is minus 1, so it's minus 1. And then positive I. And what we're going to do is distribute these together right here. So x times x gives me x squared. You see that? X times this right here gives me a negative x. X times I is xi. I like to put the imaginary in the back. It's not wrong if you put the I in the front, but I think it's normally we put the numbers first, the coefficient, then the variable, and then the imaginary part in the back. So that's why I like to put it in the back. So now we do the same thing with the negative 1. So we distribute that. So negative 1 times x gives me negative x. Then we go negative 1 times negative 1 is positive 1. Negative 1 times positive I is negative I. Then we do the same thing for this one. So negative I times x gives us negative xi, right? And then negative 1 times negative I times negative 1 is positive I. You could put a 1i, but we'll just leave it as I. And negative I times positive I becomes a negative I squared. Okay, now the thing with these boxes then, you can go in and see if you can cancel anything out. So for example, let's see, what can we cancel out? I could probably cancel out is this and this, right? I can cancel out this and this. So I'm left with, then I got to combine like terms right here. So let's write that out. So I have is x squared right there in the top, this part right here. I can combine like terms right here. So that's going to give us negative 2x, right? Then I have is a plus 1, which is this part right here. And I have this part right here, which is a negative I squared, and I squared is negative 1, right? So then that becomes a positive 1. So then we have is then x squared minus 2x, and then this becomes positive, so it's plus 2 right there. So all of this distribution part of it comes out to this part right here. Okay, but wait, we're not done, because remember, that was this part right here. I still have is this part right here, so we have to put these guys now together. And so this is where I'm saying is that maybe the box method may work out better, because then you don't have to worry about that. So let's go ahead and do another box for these two now. So this is going to be a 2 by 3 this time. So let's see, 2 by 3. So I have 2 rows and 3 columns, right? So something like this. So this is going to be x squared and then minus 3. The other one's going to become x squared and then minus 2x and positive 2. Okay, so we continue on distributing. So x squared times x squared gives me x to the 4th. X squared times negative 2x is negative 2x to the 3rd. X squared times 2 gives me 2x squared. Then with negative 3 times x squared is negative 3x squared, right? Negative 3 times that gives me positive 6x. And negative 3 times that gives me negative 6. Okay, so again, go back and see if we can cancel anything out. It doesn't look like I'm going to be able to cancel anything out, but I can combine like terms with this one and this one right there. So the final answer is going to become x to the 4th. Then this one is going to be x cubed, so I'm going to go ahead and put minus 2x cubed. Then combine these guys right here, so it's negative 3 plus 2 is minus 1 x squared. And then we have this positive 6x, right, which is this part right there. And the last part, which is minus 6. So that becomes a final answer for that example right there. Okay, so whenever you have like, 2, 3 terms and it looks messy, I would suggest putting it into this box format right there and distributing it, so then you can combine like terms and it makes it easier and clean. So that will be your final answer right there. All right, so those are 2 types of examples that we'll do on the My Math Lab, that you're going to go ahead and distribute things and combine like terms and etc. Okay, but we're not done. We still got a couple more things to do. So the next example is example 3. And this one right here is going to ask us to find the rational zeros theorem. So basically everything that we've done so far up to this point in this chapter is for this problem right here. So I have is at 3x to the 4th minus 11x cubed and then plus 10x minus 4. So what we're going to do is we're going to try to find all the roots. Now, finding the roots on this, if it was x squared like the last chapter, then it would be easy, because then I could just do the quadratic formula. I can factor or complete the square, right? But since it's x to the 4th, I can't do that. So we have to figure out is what are all the possibilities of this. So there's this method called the P and Q, and then P divided by Q. So P is always the one at the end right here. This is going to be considered your P. And then the Q is always going to be in the front. So the coefficient that's in the front right there. So we're just looking at is the coefficients. We're not looking at the variable x to the 4th right there. Okay. So what we're going to do is we're going to find all the multiples of the P. So all the multiples of 4 is going to be plus and minus 1, plus and minus 2, and plus and minus 4. Those are the multiples, because 2 times 2 is 4, and then 1 times 4 is also 4. Now, although this is negative right here, we're not sure if it was positive 1 times negative 4 that made that, or a negative 1 and a positive 4. So that's why you have to do plus and minus for those, because you're trying to find all the different combinations. Okay? Now, do the same thing for the Q. So the Q is the multiples of 3, so that one's easy, plus and minus 1, and then plus and minus 3. Okay, so the next part now is then P divided by Q. So literally what you're going to do is we're going to take each of these numbers, and then this is going to become the denominator. So it's basically 1 divided by 1 right here, which is 1. So you will get plus and minus 1. So then 2 divided by 1, right, because this is the denominator right there, is going to be plus and minus 2. And then we do the same thing. 4 divided by 1 is plus and minus 4. Now we go to the other direction with 3 as a denominator now. So 1 divided by 3 is a fraction, so it's 1/3. And then we do 2 divided by 3 is plus and minus 2/3. And the last one, 4 divided by 3, it becomes plus and minus 4/3. Now, if it comes out to something like, let's say 6 was another combination and 6 divided by 3 is 2, and you've already written 2, don't write it again because then that gets a little confusing because you're trying to find out is what are all the different possibilities. So from here, this is the key right here, the p divided by q, because we're saying that from this area right here, any of these combinations can become my roots. So I would have to test it out just to see is it positive or -1, positive or -2, etc. Now there's a couple ways to go about doing this as well. You can do the remainder theorem, which I would highly suggest just because it's probably the easiest, or you can do synthetic division. So when we do the remainder theorem, remember, when we substitute the numbers into the original equation, we're trying to find out if it equals 0, right? Because if it equals 0, then it means it's a root. If it does not equal to 0, it's not a root. So same thing, you can do the synthetic division. You can put this into synthetic and see if it equals to 0 on your remainder. And if it does, then it's a root. If not, then it's not a root, okay? So pick a number, any number, but as long as it's one of these numbers. So for example, we're saying that +1 is a possibility or -1 is a possibility. Now it's not a guarantee, so these are possibilities. So from this combination, you could see I wouldn't choose, like for example, 3, because 3 is not even one of the lists of the numbers, right? So you wouldn't pick like 10. That's not one of the list. But you can pick it as like -1/3 or +2/3 or any of these other ones right here, okay? So pick any of these numbers, substitute it back into the original equation, which is this part up here. This is the original. See if it equals to 0. If it equals to 0, it's a root. If it does not equal to 0, it's not a root. So let's pick a number. I'm going to go with -1. Okay, so I'm going to go back and put it up here. So to show work, I'm going to go ahead and do it up here. So it's -1 to the 4th power. Then I have it's -11, -1 to the 3rd power, plus 10, -1, and then -4. Okay, so from here, this becomes positive, right? So that's +1 times 3 is 3. Then I have negative right here. So negative times 11, -11, becomes +11 right there. This becomes -10. So -10 and -4. So let's see, if I add that up, this becomes 14 right there. And this is -14. Perfect. It comes out to 0, so it's a root. So if it's a root, -1, then I'm going to go ahead and do the synthetic. So this is kind of what we did in the last class session. So we put in -1 into here, and we start doing this so I can get the equation going. So again, this part right here is a coefficient only. So the coefficient is 3. So that's 3. -11, so -11, 10, and -4. Okay, so here we go on the synthetic. Oops, we're forgetting something. X squared. Oh, there is no x squared. Okay, so x squared should be 0, +10. Okay, so +10, and then -4. So pay attention to those things because that's going to obviously affect this right here. Okay, so here we go. So we're going to drop down the 3. 3 times -1 is -3. -11 plus, because remember that's the operation, it's synthetic. So plus becomes -14. -14 times that becomes +14. So this becomes 14. 14 times that becomes -14. So we have is -4, right? And then -4 times -1 becomes +4. Perfect. It's 0, right? Because we knew it's going to come out 0. But if it didn't, then that's when you have to go back and check to see if you have either all the coefficients correctly or if you added and multiplied correctly right here. Okay, so once we're here, what power are we on? So that's, remember, determined from the highest up here. So if this is right here is x to the 4th, we subtract 1, we're on x to the 3rd down here. So if it's x to the 3rd, we still have another one that we're going to do because we want to get to is x squared. So we would have to test out another number to make sure it works. And another number that works is 2/3. So 2/3 would be the number. Now, if you didn't know, obviously you would have to test it out. So using the remainder theorem, you would go ahead, put it back into the original equation right here and see if it comes out to 0. If it does, then great. If not, then you move on to another one. Now, if you have a fraction like 2/3, please make sure you put in the calculator 2 divided by 3. Do not put 2/3 as a decimal as 0.667 and round off, because then you'll never actually get a 0. Okay, so make sure you put all of that fraction in. Okay, so here we go. So if I bring the 3 down, 3 times 2/3. So let me just do that on the side. So 2/3 times 3 like this, right? So the 3's can cancel out. You're left with a 2. So that's 2, this part right here. Negative 14 plus 2, because remember this is a plus, is negative 12. So then 2/3 times 12, negative 12, is going to be, let's see, 3 goes into 12 4 times, so that's negative 8, right? So it's negative 8. 14 and negative 8 is 6. So 2/3 of 6 times 6 gives me, let's see, 3 goes into 6 2 times, so that's 4. And then this becomes 0, right? We love it. Okay, so now, where are we right now? So this, remember, is to the 4th. This is x to the 3rd. So this is x squared. So once we're x squared, you can actually continue on and start doing more of these and check to see if anything else works. But not always does it always work. So when you get to here, since it's the quadratic equation, you can go ahead and do either the big X method, you could do the quadratic formula, or completing the square. So I'm going to go ahead and see, well, first of all, 3 can actually be factored out. So let's go ahead and factor out a 3, because then that makes it smaller. So we have is x squared minus 4x, right? And then plus 2, because that's going to give us 6. So I set it equals 0 because I'm going to solve for x. So technically I'm going to divide by 3 on both sides, divide by 3. So we have left is x squared minus 4x plus 2. And if I try to do a big X method, it's probably not going to work because AC is 2. And then the b is negative 4. There's no way we're going to make a combination of 2 and come up with negative 4. So we're going to have to do completing the square or the quadratic formula. So since everybody likes the quadratic formula, let's go ahead and do the quadratic formula. So here's my a, here's my b, and here's my c. So it's negative b, so it's negative 4 plus or minus the square root of b squared. So it's negative 4 squared minus 4ac, and then all divided by 2a, which is 1. Okay, so then if I simplify that, that becomes 4 plus or minus the square root of, let's see, that's 16, and this is 8, so 16 minus 8 is 8, all over 2. And 8 can be factored out, right? Because that's your little factor tree. 8 is 4, 2 and 2, so that comes out, and this stays in. So it becomes 4 plus or minus 2 square root of 2 all over 2. Now, to factor this out, you got to legally do this, so don't go cancel and stuff. So factor out a 2 on the top. This becomes 2 plus or minus the square root of 2, right? Because this goes in, becomes a 4. This goes into here, becomes a 2 square root of 2, and then all over 2. So this can cancel out right there. So your final answer then, final for this, is 2 plus or minus the square root of 2. So we have to go back and find the roots, right? Because that was, this part right here is finding is all the roots. So we said previously that if it's x to the 4th, this tells me how many roots I have. So I should have 4 roots. So what are my roots? X equals, one of them being the negative 1, right? So x equals negative 1 is one of the roots. The other one is x equals 2/3, right? So 2/3 is the other one. And then last two, x equals, and that was this part right here. So, because it's a plus and minus, so you have to split that up right there. So it's 2 plus the square root of 2 and 2 minus the square root of 2. So 2 plus the square root of 2 and then 2 minus the square root of 2. So that becomes 4 of your roots right there, right? Because it says 4 right there, okay? So that's the rational zero theorem. Okay, one more we got to do. And the other one is called the Descartes rule of sign right here. Now, the purpose of Descartes rule of sign just tells me, it's kind of like, remember when we did last chapter, when we did the discriminant inside the square root, that b squared minus 4ac tells us how many roots there are. Well, it's the same idea with this one, but that one on the discriminant only works when it's a quadratic, because it has to be x squared minus something x plus some number for c, right, in order to do the discriminant. But in this case, in the Descartes rule, it says that I can use it for any of the powers, and I can try to figure out is how many possible roots will there be. So these are now different possibilities. It's not for sure until you actually do pretty much what we just did on that last example, example 3, and the rational zeros. So in this one right here, Descartes' rule says you're looking for is the sign change. So for example, like this right here is positive 2, this is a negative 3. So if this is a sign change, it's like the intermediate value theorem. Remember, we just did that one. So the intermediate value theorem says that if there's a sign change in between it, there is a possibility of a 0. Well, the same thing with Descartes' rule, that if it's a positive and a negative, there's a possibility of a root being in between there right there. Okay? Then we have as another sign change from negative 3 to positive x right here. So that's another change. And then there is no sign change here because it's positive to a positive. So there's no for that one. So what we're going to do then is in kind of make a chart right here. And I'm doing this the possibility of roots. So looking at this, 5 is the number of possibility of roots. So I'm going to go ahead and put 5 right there. And then the possible or the positive roots. So this is called the positive roots. So from the original equation, you're just counting up to see what is the possibility. So there's 1, 2 possibilities. So that's 2 right there. And then to find the negative roots, we're going to go ahead and substitute in negative x into all the x right here. So right here, it's going to look something like this. P of negative x is equal to, and then you put in 2 negative x to the 5th. So you're not changing anything but putting a negative inside, because what's going to happen is it's going to change the sign possibly. And then that's what you're looking for. So negative x plus 4 like this. Okay? If I simplify this, anything to the odd power on a negative will give us a negative. So your final answer becomes negative 2x to the 5th like this. So you're just pulling out a negative or a positive. That's what you're concerned with. So this is anything to an even number cancels out to a positive. So it's positive times negative is a negative. So that's a negative 3x squared. This is going to become positive times negative is a negative. So negative x and then plus 4. So what you're going to do is the same thing as what we just did up here. You're trying to figure out, is there a sign change? So there is no sign change right here because it's negative to a negative. There is no sign change right here because it's negative to a negative. But there is one sign change right here because it's negative to positive. So in this one right here, we're going to put it underneath the negative root. We're going to say there's one sign change right there. Okay? Now, what happens is then from here, you're looking for all the possibilities. So for this one right here, a 2 and a 1, and we said 5 is the maximum, so you have to add this up. So 2 plus 1 is 3. So you're missing then is 2 imaginary. So there's a possibility of getting 2 imaginary numbers, because then that's 2 plus 1 is 3, 4, 5, and the 5 is being the total possible roots. Okay? Now, here's the rule for also Descartes that says that if you have something like this, the positive roots, you're going to subtract it by an even number like a 2. And most of the time it's minus 2. So just go with minus 2. And for the next possibilities. Now you can't have a negative. So it has to be a 0 is the lowest you can go on this. So for example, if I go 2 on this, I go 2 minus 2 is 0. There's a possibility that I can have a 0 here and a 5 right here, right? And then I would have to do is a possibility of 1 right here. Now this doesn't change. I'm only changing 1 at a time. So this right here changes. So then this I do not change. And then I just play around with this imaginary right here. This has to add up right here. All of this has to add up to a 5 because we're saying 5 is a possibility. So if there's 1 right here, 5 minus 1 is 4. So there's a possibility of getting 4 imaginary numbers right there. Okay? Another possibility you would go into is a negative right here. But the problem is if I go minus an even number, which is a 2, 1 minus 2 is a negative number. You can't have a negative number roots. So then in this case, this doesn't work right here. So you're finished with this problem as these two possibilities. There's a possibility of getting 2 real roots on the x-axis, 1 negative, right? And then 2 imaginary, which means it's floating somewhere up on the x-axis. There's also the possibility of getting no real roots on the positive, but 1 negative and then 4 imaginary right there. Okay? So one more try on the Descartes just to make sure we understand this. So again, looking for the signs for the positive. So the possibility is 4 right here. So we're saying the 4 is a possibility of number of roots. And then from here, we're looking for sign change. So here's 1 sign change because that's positive to a negative, right? That's 1. There's 2 right there because it's a negative to a positive. there's 3, and then there's 4 sign change right there. So I'm going to put 4 positive sign changes right there. Okay? To get a negative sign change, we substitute a negative into this equation, the original equation. So we put a negative x inside here equals 5 negative x to the 4th. We're writing exactly the same, except just putting in negative x to the each of those parts right there, substituting that in. Negative x to the 2nd power minus 12, negative x, and then plus 4. Okay? So we just simplify. So if it's anything to an even power, it's going to cancel it out. So that becomes positive 5x to the 4th. Anything to an odd power is negative. So this is negative times negative is positive. So it becomes 3x to the 3rd. This is positive, right? Because negative times negative is positive. So that doesn't change anything for us. So x squared. And then this becomes positive because it's negative times negative is positive. So positive 12x and then plus 4. So we're looking then for a sign change. So it looks like there's nothing here. There's nothing here. There's nothing here. And there's nothing here. So there is 0 on this negative sign change right here. Okay? So if it's 0, we said, remember, these 3 boxes have to add up to the total possible. So this is already a 4, so this is going to become a 0 because 4 plus 0 gives us 4 right there. Okay? Now, what's the other possibility? So now going this direction, we're going to subtract 2 on this right here. So 4 minus 2 is 2, so that's a possibility. This one right here, you can't subtract by a 2 because 0 minus 2 is a negative. You can't have a 0 or a negative. So this one right here is going to be still a 0 right here. So this one doesn't change. So then somehow I need to get a 4 right here, right, to add up to get a 4. So there's a possibility of getting a 2 imaginary. And I can probably do one more on this part right here because if I minus 2 again, so 2 minus 2 is 0. So here's a 0. Again, this one doesn't change. So then this would have to be a 4, right, for that 4 right there. Okay? So then we're saying all of this right here. There's 1, 2, 3 different possibilities for this equation. If I do the synthetic division and finding all the roots and stuff like that, that this answer will come out either 4 positive roots or 2 positive and 2 imaginary. The imaginary, remember, is the I part of it, you'll see. Or it's a possibility that all 4 of them becomes an I right there. So that's what Descartes' rule says. So go ahead and rewind this video on any of these parts if you don't understand something.